We are going to work now on inverse functions. It is section 6.2 in our book, and we are going to review how we find inverse functions and what they are. So what are inverse functions? Imagine we have a set of numbers and another. This is my domain, this is my range, and the elements in the domain, I multiply them by 2. I find double, and I'm calling that my function f of x. If I go backwards, if I get from an element in the range of f and I get to an element in the domain of x, I'm doing the inverse function of x. So basically, f of x is going to be multiplying x by 2, and f inverse of x is going to be divide x by 2. I go backwards. So given a function, how do we find the inverse function? We are going to follow 3 steps. Our first step is replacing f of x with y. Our second step is going to be interchange x and y, and our third step will be solve for y, and then we are done. We have an example here. This is the function that we start with, and this will be the inverse function that we get when we are following those steps. Look, if we graph, this is the initial function and this is the inverse function. So you're normally going to have some symmetry when you graph a function and its inverse. We are going to work now on an example here. This first one, example number 1. We are going to do this process. So my f of x that I'm going to find the inverse of is 2/3 of x minus 1. The first step that I'm doing is replace f of x with y. So that will give me y is equal to 2/3 of x minus 1. Now I'm going to exchange x with y and y with x, and I'm going to get that x is 2/3 of y minus 1. I don't do anything. I just, where I have y, I just write x, and when I have x, I just write y. And now I'm going to solve for y. To solve for y, what I have to do is first add 1 both sides, and I'm going to get x plus 1 is equal to 2/3 of y. 1 and negative 1 are gone. Now I'm going to multiply both sides of my equation by 3 divided by 2, both sides. So what I'm going to get is 3/2x plus 1 times 3/2 is 3/2. And the 2 goes away with the 2, the 3 goes away with the 3. So when I simplify this side, I just get y. So this is going to be my inverse function, but I'm going to use the function notation, and instead of y, this one that I calculated was inverse function of x, and it's going to be 3 divided by 2 times x plus 3 divided by 2. This will be a good way to getting that function. So I can simplify, I can graph it, sorry, I'm not simplifying, I already did. I can graph it because in this notation, slope to graph is going to be 3/2, and the y-intercept is going to be 3/2. So the slope is the coefficient of the x, and the y-intercept is the number that doesn't goes multiplied by x. So if I'm graphing that function, I'm going to start at 3/3 is the y-intercept. So I go to the y-axis and I find 3/2, 1, 2, 3 half will be around there. And then I'm following the y-intercept. So I'm going to go 2 to the right, 3 up. So 2 to the right, 1, 2, 3 up. That will be my next line. 1, 2 to the right, 1, 2, 3 up. 1, 2, 1, 2, 3. And I can trace there my line nicely. I join the point and I got my inverse function. So this is the inverse function. If I want to represent also the original function, it was f of x is 2/3 of x minus 1. So here the slope is going to be 2/3. The y-intercept is going to be -1. So I'm starting at -1 and going 3 to the right, 2 up. I'm going to start at -1 here, 3 to the right, 2 up. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I can go backwards. And now I'm going to trace my new line, the original function, and you see that you always get some symmetry that you can see there. And this is the way we find inverse functions following the 3 steps, and then we graph them because we get a function in the slope-intercept form, which is very easy to graph. Do your homework. Bye.